Hello and welcome back to the course of Fundamental of Electronics and Electrical Engineering. The topics that I am going to discuss in this video lecture are Norton theorems and superposition theorem. In the previous video lecture, I have already discussed about network theorem and one of the network theorem, that is Thevenin's theorem. In this video lecture, I am going to discuss the remaining two theorems. So let us start with the first one, that is Norton's theorem. Basically, Norton theorem is a dual of Thevenin's theorem. Now, what is a statement and why it is dual of Thevenin's theorem? Let us understand. So, any linear, bilateral and active network, all these three terms I have already discussed in the previous lecture. Linear means what? The element for which VI characteristics remains linear. Bilateral means what? The elements for which if current direction is reverse, then VI characteristic does not change. An active network means what? The network which consists of and elements like energy sources. So any statement is what? Any linear bilateral active network with two output terminals can be replaced by a current source denoted by ISC in parallel with equivalent resistance Rn between the output terminal AB. Now what is ISC and Rn? So ISC is a Norton's equivalent current source. It is a short circuited current flowing through short circuited output terminals. In the Thevenin's theorem, as you know, the branch in which current is to be determined is removed, but here the branch in which current is to be determined is short circuited, and Rn is Norton's equivalent resistance. Rn can be found in similar way like RTH that we have done in the previous lecture, that is a Thevenin's equivalent resistance. It is the equivalent resistance of the network when looked back into the network from open circuited terminal after replacing all the sources of given network by their internal resistance. So Rn is found in similar way as we have found the RTH, but here in the Thevenin's theorem we have found VTH, but here we are finding out the ISC, that is a short circuit current. Now statement is clear if we look at this network which consists of one block which consists of number of loops and one network, that is RL. So basically the network is divided into the two parts. The one part is from left hand side of AB and one part is from right hand side of the AB terminal. Now this network can be converted in a simple network using Norton's theorem. So this network can be converted into one current source in parallel with resistance Rn, and then finally connecting back the network, the branch in which current is to be determined. So in the previous case, in the case of Thevenin's theorems, we have found VTH and series RTH. Here we are finding out the short circuit current, and current is always parallel with resistance, short circuit current in parallel with Rn. So this network can be converted into the simple network consisting of one current source in parallel with Rn. Current is found by short circuiting the branch in which current is to be determined, and Rn is found in similar way as we have found RTH in the case of Thevenin's theorem. And finally connecting back RL. So here we'll be having, if we finally we want to determine the IL in the given network. So if we want to determine IL over here, so we have to apply the current division rule. We have already studied the current division rule. Current division rule come into the picture when the resistance are connected in parallel. So Rn and RL are connected in parallel and input current is IS. So easily applying current division rule we can find the value of IL. So in the final step current division rule will be applied. Now this is nothing but the Norton's equivalent circuit. Now to understand one example I am taking, suppose it consists of three resistance R1, R2, R3 and one other resistance, that is RL. Now we have been asked to determine the current flowing through RL. Now first step is what? In the first step we have to remove RL and short circuit the terminals AB. So if we will short circuit the terminal AB, the network will look like this one. So remaining part of the network will remain as it is, and AB terminal is short circuited, and that short circuited current is denoted by ISC. Now how we can find ISC? Now R2 and R3 is in parallel and ISC is flowing from R3. So we can find ISC by applying current division rule. But to determine ISC we need to have the total current I. So to find the total current I of the entire network, we have to find first the total resistance of the entire network. So to find the total resistance of entire network, we have to look from this side. So what is total equivalent resistance? So we can say R3 and R2 are in parallel, and this parallel combination is in series with R1. So R is equal to R1 plus R2 parallel R3. That is nothing but the R1 plus R2 R3 divided by R2 plus R3. Now total current I can be found by applying Ohm's law. So I is equal to E divided by R, where R is the total resistance of the entire network. Now we have found the I. We can find out the IAC by applying the current division rule. So IAC is equal to total current I into opposite resistance. IAC is flowing from R3 and opposite resistance of R3 is R2. So IAC is equal to I into R2 divided by R2 plus R3. Now, next step is what? Replacing all the sources by their internal resistance to determine Rn. We have determined the IAC. So, battery E is replaced by short circuit because voltage sources are always replaced by short circuit and current sources are replaced by open circuit. Now, whenever we want to determine Rn, we have to look from the open circuited terminal. We have to look back into the network from open circuited terminal AB. In the previous case, we have found the R in the step 2. R we are finding from this side, but keep in mind that whenever we are finding the Rn, we have to look back from the open circuited terminal AB. So Rn is what? Rn is R1 parallel R2 plus R3. So Rn is equal to R1 parallel R2 plus R3. And total resistance we have found in the step 2 was R2 parallel R3 plus R1. So this is the point to be remembered. Whenever we are determining the equivalent resistance, Norton equivalent resistance, we have to look back into network from the open circuited terminal. So Rn is R1 parallel R2 plus R3. Now step 4, replace entire network by Norton's equivalent circuit. So we have found the IAC and Rn. So IAC is placed in parallel with Rn and finally connecting back RL to determine the current flowing through RL. So now in this network, equivalent network, we are connecting back RL and current flowing through RL is IL, which we have been asked to determine. So IL can be found by applying a current division rule. So IL can be written as total current IAC into opposite resistance divided by Rn plus RL. So IL is equal to total current is what? IAC. Here we have already found the total current, that is nothing but the IAC. Input current to this branch, that is IAC. So IL is equal to IAC into opposite resistance. Opposite resistance of RL is Rn. IAC into Rn divided by Rn plus RL. Now let us take one example based on Norton's theorem. So here one network is given. In this network, we have been asked to determine the current flowing through this 5 ohm resistance, that is current flowing through branch AB, between terminal AB. So starting with the first step, short circuiting branch through which current is to be asked. So 5 ohm resistance is first removed and that branch is short circuited. So terminal AB is short circuited. So now network looks like this one. Now current flowing through 5 ohm between point A and B is nothing but the IAC. So we have to first find out the IAC. Now how we can find out the IAC? So to determine IAC, we need to have the value of this current I, that is a current entering in these two parallel resistors. So to find the I, we need to have the total resistance of the entire network, and finally we can have the value of I. So finding out the IAC, that is the second step. So how we can find out the total resistance of the network? So we have to look back from here. So total resistance R is equal to 5 parallel 10 plus 10. So R is equal to 10 plus 10 parallel 5, and that is nothing but the 13.33 ohm. Now total current I of the battery is given by I is equal to 120 divided by total resistance of the network, and that resistance is found when you are looking back from this side, from left to right side. So I is equal to E divided by R, that is 120 divided by 13.33, that is 9 ampere. Now using current division rule, we can easily find out the IAC because now we have the value of I. So IAC is equal to I into opposite resistance. Now ISC is flowing from 5 ohm resistance. So opposite resistance becomes 10 ohm. 10 and 5 ohm are in parallel. So ISC is equal to I, that is 9 into opposite resistance 10 divided by 10 plus 5, that is 19 divided by 15, that is 6 ampere. So value of short circuit current which we are getting is nothing but the 6 ampere. Now the next step is to determine the RN, that is equivalent resistance. So we know to determine RN we have to replace all the sources by their internal resistance. As the given network consists of only voltage source, that source is replaced by internal resistance, so voltage source is short circuited. Now whenever we are determining RN, we have to look back into the network from open circuited terminal, that is AB. So we are looking from right to the left side. So AB is equal to 10 parallel 10 plus 5. So that is nothing but the 10 ohm. 10 parallel 10 is nothing but the 5. 5 plus 5, that is 10 ohm. So equivalent resistance of the network RN is nothing but the 10 ohm. Now connect 5 ohm back to its terminal AB and find the current through it. Now this is 6 ampere is ISC. RN which we are getting is a 10 ohm. So this is the Norton equivalent circuit. Now between terminal A and B, open circuit terminal, we are again connecting back 5 ohm resistance through which we have been asked to determine the current. So now IL can be easily found by applying the current division rule. Input current to these both parallel branches is 6 ampere. So IL is equal to ISC into RN. RN is nothing but the 10 ohm divided by 10 plus 5. So 6 into 10 divided by 10 plus 5. So 60 divided by 15, that is nothing but the 4 ampere. So current flowing through RL, that is 5 ohm, is 4 ampere. So this is how we can found the current flowing through any branch using Norton's theorem. The step 1 is short circuit the branch through which current is to be determined. Then finding out the equivalent resistance RN. RN can be found in similar way like RTH. And then finally drawing the Norton's equivalent circuit, that is ISC in parallel with RN, and connecting back the branch through which we have been asked to determine the current. And in the final state we can find the current through load resistance using current division rule. So this is all about the Norton's theorem. Now let us move toward the another theorem, that is a superposition theorem. Now first, superposition theorem is used to solve the electric network which is having more than one energy source. If the circuit or network contains only one energy source, then we cannot apply superposition theorem. It is having limitation that it is applicable to only linear circuit, the circuit which consists of linear elements like resistance. If the circuit contains non-linear elements like diodes and transistor, then we cannot apply the superposition theorem. So which are the conditions to apply the superposition theorem? The first one, the circuit should have more than one energy source, the circuit should have only linear element, and the circuit should have independent sources. Now what is this statement? In a linear bilateral network which consists of more than one energy source, the resultant current or voltage flowing or voltage across the branch flowing through an element can be found by considering each source separately, individually, while all other sources are replaced by their internal resistances, and then finally algebraically adding current due to each individual sources. Now to understand the superposition theorem, one network is that which consists of more than one energy sources. Here E1 and E2 are the two sources. Now suppose we have to find the current through R2 using superposition theorem. So according to the superposition theorem, first we have to consider one source. Suppose we are considering E1, then we have to replace E2 by the internal resistance, that is we have to replace E2 by short circuit, and finding out the current through R2 because of E1 and noting down that current. Now in the second step we have to consider E2 and we have to short circuit the current E1, and we have to find the current through R2 because of E2, and finally adding both the current algebraically. And this is the procedure to determine the current flowing through any branch using superposition theorem. This is clear. This will be clear if I take one example. So let us take one example. Example 1 based on superposition theorem. So here one network is there which consists of two sources. One is a voltage source and other one is a current source. In this network, we have been asked to determine the current flowing through 9 ohm resistance using superposition theorem. So first we have to consider one source. Suppose we are considering, according to the superposition theorem, consider only one source at a time. So consider 3-volt source alone and replace current source by their internal resistance. Current sources are replaced by open circuit, voltage sources are replaced by short circuit. So the new network becomes this. Now as current source is replaced by open circuit, this branch is eliminated. Now current flowing through 9 ohm using 3 volt we have to find in the step 1, and that is denoted by I9 dash. So easily we can apply KVL to determine I9 dash. So I9 dash is equal to 3 divided by total resistance of the circuit, that is 6 plus 9. So 3 divided by 15, that is 0.2 ampere. Now this current is flowing from A to B. So this thing you have to remember the current direction, because it is not necessary that in each case the current will be flowing in the same direction. There is some example in which if we consider the second source, then current direction of current will be reversed. So here in the first case, when we are considering 3-volt battery, the current is flowing from terminal A to B, and that current is nothing but the 0.2 ampere. That is nothing because of 3-volt battery. Now in the next step, consider only 2 ampere source alone and replace voltage source by the short circuit. Now this voltage source is replaced by short circuit. So now current flowing through 9 ohm, that is through branch AB, is now denoted by I9 double dash. Now in this case, again the current direction is same in this case. Now we can find the current flowing through 9 ohm using current division rule, because input current is 2 ampere and both these branch are in parallel. So we can easily apply KVL to determine I9. We can apply the current division rule to determine I9 double dash. So I9 double dash is equal to total current, that is 2 into opposite resistance, that is 6, divided by 6 plus 9. So 12 divided by 15, that is 0.8 ampere. And this current is also flowing from A to B. So in both the cases, current is flowing in the same direction. So both currents will be added. If current directions are reversed, then we have to take the subtraction of the current. So final value of the current, that is current flowing through 9 ohm resistance, is given by I9 is equal to I9 dash plus I9 double dash, that is 0.2 plus 0.8, that is nothing but the 1 ampere. So this is the procedure to determine a response using superposition theorem. We have to consider one source at a time and we have to replace the other sources by their internal resistance, and we have to note down the effect of that source, and finally algebraically, that's why the word in the statement word algebraically is used, because it is not necessary that every time we have to take the addition. That depends on the current direction in both the cases. In this case, current is flowing in the same direction whenever we are considering 3-volt battery or 2 ampere current source. So both are added. So final current flowing through 9 ohm resistance is 1 ampere. Now let us take another example based on superposition theorem. So in the given circuit, we have to find the current through all the resistances, that is current through 10 ohm resistance, 3 ohm resistance and 5 ohm resistance using superposition theorem. And the network consists of two sources, both are voltage sources. So we have to first consider, suppose we are considering 50 volt source in the step 1. Now, so network looks like this one. 25 volt battery is replaced by short circuit. Now current flowing through 10 ohm is I1 dash, flowing through terminal AB, that is I2 dash is 3 ohm, and that flowing from 5 ohm resistance, that is nothing but the I3 dash. Now we have to determine I1 dash, I2 dash and I3 dash, because we have been asked to determine current flowing through all resistance. Now first we have to find out the total resistance of the circuit to determine I1 dash. So total resistance of the circuit or resistance across 50 volt battery is, so we have to see from left hand side to the right hand side. So that is nothing but the 5 parallel 3 plus 10 ohm. So 10 plus 3 parallel 5, that is, if we solve this, we are getting 11.9 ohm. Now we can find the current supply by 50 volt, that is nothing but the I1 dash, that is nothing but the I1 dash is equal to 50 divided by total resistance of the circuit, that is 11.9, so 4.2 ampere. So I1 dash is 4.2 ampere. Now we can easily find I2 dash and I3 dash using current division rule, because input current is 4.2 ampere. So current in 10 ohm resistance is nothing but the 4.2 ampere. current in 3 ohm resistance, that is I2 dash is equal to total current, that is 4.2 into opposite resistance, that is 5 divided by 5 plus 3, that is 2.63 ampere. And current flowing through 5 ohm resistance is given by total current into opposite resistance divided by sum of resistance. So 4.2 into 3 divided by 5 plus 3, that is nothing but the 1.58 ampere. So whenever we are considering 50 volt battery, I1 dash is 4.2 ampere, I2 dash is 2.63 ampere, and I3 dash is equal to 1.58 ampere. Now consider 25 volt source alone. So 25 volt source, now in this case current directions are reversed, because now 25 volt battery is considered, so current is flowing from this direction. Here direction of I1 and I3 dash are I1 and I3 are reversed, and direction of I2 remains as it is. 50 volt battery is replaced by their internal resistance, that is short circuit. Now in this case we have to find out first total resistance to determine the current supplied by 25 volt battery. So to determine the total resistance, we have to see from this side. So total resistance becomes 10 parallel 3 plus 5. So 5 plus 10 parallel 3, that is nothing but the 7.31 ohm. That is the resistance across 25 volt battery. Now current supplied by 25 volt battery is nothing but the I3 dash, and that is current flowing through 5 ohm resistance. So that is nothing but the 25 divided by total resistance of the circuit. So 25 divided by 7.31, that is nothing but the 3.42 ampere. Now current flowing in 3 ohm and 10 ohm can be found by applying a voltage division, because input current, we know input current is 3.42 ampere and both these branches are in parallel. So I2 dash is equal to 3.2 into opposite resistance, that is 10 divided by 10 plus 3, that is 2.63 ampere. Now current flowing through 10 ohm resistance is given by I1 double dash is equal to input current 3.42 into opposite resistance, that is 3 divided by 10 plus 3, that is nothing but the 0.78 ampere. So now finally calculating the all current, that is I1, I2 and I3. So we have to take the algebraic addition. Now we have to, in both the cases direction of I1 and I3 are reversed. So in that case we have to subtract lower value from the higher value. In the case of I2, the direction are same in both the cases. So we have to take the algebraic addition. So first current flowing through 10 ohm resistance, that is I1 is equal to I1 dash minus I2 dash, that is 4.2 into 4.2 minus 0.78, that is 3.42 ampere. Current flowing through 3 ohm resistance. Now in 3 ohm resistance current direction is same in both the cases, so both are added. So 2.63 plus 2.63, that is 5.56 ampere. And current in 5 ohm resistance, that is I2 is equal to I3 double dash minus I3 dash, that is 3.42 minus 1.58, that is 1.84 ampere. So only thing to be remember whenever we are doing this, whenever we are applying the superposition theorem, is the direction of the current. If the direction of the current are reversed, then we have to take the subtraction. If the direction of the current remains same, then we have to take the addition. So this is how we can calculate the current or voltage using superposition theorem. So this is all about the today's video lecture. In this video lecture I have discussed Norton's theorem and one example based on Norton's theorem, superposition theorem, and one example based on superposition theorem. Hope you have enjoyed the video. See you soon in the next video. Thank you for watching.